Hello, Tech World. This is Tech Thoughts. In this three-part video series, I'm going to be exploring the topic of subnetting. When you've completed all three videos, you'll have an understanding of what subnetting is for, and you'll be able to properly calculate subnets. This is the third video in the series where I'll be exploring Class C subnetting. If you haven't yet seen video 1 on binary conversion and video 2 on IP properties and classes, I highly recommend you check those out first. I've linked them in the comments below. If you're already comfortable with those topics, then let's go ahead and get started.
So at this point, you should be able to look at these two IP addresses and be able to identify immediately that they belong to separate networks and cannot communicate without the use of a router. So we have a typical Class C address here, which is locking in the first 3 octets, making this all belonging to the network, leaving this open for the host. Same here, typical Class C subnet mask, locking in this 3 octets and leaving this open for the host use. And because these are locked in, and this is 237, and this is 101, these are different networks and will require the use of a router to communicate with one another. If you find this to be confusing at this point, you definitely need to go back and check out videos 1 and 2 and get up to at least the speed of being able to recognize why this is the way it is. So now we're going to talk a little bit about slash notation. Up to this point, we've been writing our subnet masks out as 255.255.255.0. But a shorthand and a way to write this is using slash notation /24, and I'm now going to explain why /24 equals this and why that equals /24. So when we write this out in binary like we have in the past, we end up with 8 in each of these 3 octets, and of course 0 in this last octet. And if we add 8 plus 8 plus 8, we get /24. So another way I could do this is write a /8, which is also known as Class A. And I could, of course, write my octets out, and I get 8 in the first one. And of course, since this is only /8, I know that these will be 0. I can also do a /16, which you should now be catching on. That will populate the first 2, leaving the last 2 octets as zeros, also known as a Class B. So /24, Class C, /8 is Class A, and /16 is Class B, and that is slash notation, just a shorthand way of indicating what a subnet mask is going to be. Okay, so we've had it pretty easy up to this point because we've been dealing with either 0 or 255. And we know that 255 populates the whole octet and it locks it in. This is all turned on, all turned on, all turned on, and this is completely turned off. So this locks in the network, and this leaves us a full range of hosts. But where subnetting becomes a little bit more complicated, and what we're going to be discussing today, is what happens when I take that 255.255.255, and I don't leave it something simple like a 0. Instead, let's say I make it something 248. What is happening here is this no longer completely belongs to the host because there are some bits that are going to be turned on here. So you are going to have some 1s turned on here to make this 248, which is going to make a part of this octet right here going to belong to the network along with all of these. And part of this is going to belong to the hosts. And our job now is to figure out is what portion of this octet here belongs to the network side and what part belongs to the host side. In order to do that, we need all of this information that is contained on this slide. I know this can seem a little daunting, but I'm going to be going through each of these sections and explaining what they're for, and I think you'll find that by the time I'm done explaining that it's actually pretty simple on how we approach this these subnetting problems. So let's start off with the subnet mask, and let's say again 255.255.255.255. 248. So again, part of this is going to belong to the network and part of it is going to belong to the host, and we're going to figure out which one is which. So we're going to start off with binary conversion. Okay, so I know these first 3 octets are all populated with 1s because they're all 255s, which turns all those bits on. But now I got to figure out how many 1s are turned on here for 248. So using binary conversion, we're going to convert 248 into binary. This binary representation right here. And I get that because 128 plus 64, 128 plus 64 plus 32 plus 16 plus 8 equals 248. Notice why I've written these numbers down here. Because as I start adding these together, 128 plus 64 plus 32 plus 16 plus 8, I can just look down and see that that is going to be 248. So I now see that the first 5 bits, I have 5 bits here, are turned on. And these 5 bits here belong to the network. And these 3 bits here belong to the hosts. And that is where these 2 numbers here come in. So 2 to the n minus 2, where n is the number of bits borrowed. So this will tell me how many subnets I have. Now I have 8 here, 8 here, 8 here, and 5 here. So I'm simply going to add those together. 8 plus 8 plus 8 plus 5. And that gives me 24 here, plus 5 gives me 29. 29 is my n. So 2 to the 29th minus 2 is going to equal my number of subnets, the actual number of networks that this subnet mask will create. I only have 3 bits left over, so I have 3. So this is my n for the number of hosts in each of these subnets. So 2 to the 3 is, of course, 8 minus 2 is going to be 6. So 6 is the number of hosts per each of these networks. So I will have the first network, and it will have 6 hosts. And the second network will also have 6 hosts. And the third network will have 6 hosts. The fourth network will have 6 hosts, etc., etc. So the last part that we have to do here is calculate the range of each of our subnets. So what I'm going to do here is, because we're dealing with an 8-bit system, and remember 2 to the 8th is 256. And remember, we are dealing with 0 to 255, and the 0 counts. So it's like 255 plus 1, which gives us 256. So I'm going to take 256, and I'm going to subtract our borrowed octet here, which is 248. And that gives me 8. 8 becomes extremely important because it is our range. So what I'm going to do here is I'm going to begin writing out ranges. I'm going to start with 0, and 8 is my number, so I'm going to go up by 8. And I'm going to continue to do that until I eventually reach 255. And then I'm going to come back and fill these in. So 0 to 7, 8 to 15, 16 to 23, 24 to 31, 32 to 39, so on and so forth. Now, the most important thing to remember here is that in subnetting, the top and the bottom are always reserved. So this is my first network, and it's the bottom, so it's going to be crossed out. It doesn't count, it's reserved. Additionally, each number in the beginning of the range will also be reserved, as well as the last number. This makes this range here actually 9 to 14 instead of 8 to 15. This is a total of 6 hosts, 9, 10, 11, 12, 13, and 14. And just like my formula stated, I should have 6 hosts on each network. Again, the second network, which is right here, is going to be actually 17 to 22. Again, being 6 hosts on the second network. And again, here on the third network, we're going to actually be 25 to 30. Again, 6 hosts. So let's take another look at another example. This time we'll make the subnet mask 255, 255, 255, and we'll make this one 224. So again, we're going to start off with binary. And of course, we have to calculate out what 224 is going to be. You can look up at your chart here. 128 plus 64 plus 32 is going to equal 224. So we know those first 3 bits are going to be turned on. And the last part is going to be off. That means these first 3 bits are borrowed and part of the network, along with all of these. And this section right here are the hosts. So that gives me 2 to the, and again, we're going to add here 8 and 8 and 8, 24 plus 3, which is 27. So 2 to the 27. Remember, where n is the number of bits that are borrowed or turned on, minus 2 is the number of subnets. And then what I have left here is 5 hosts, so 2 to the 5, which is 32 minus 2 is 30. 30 hosts per subnet. Okay, so now the last step again is to calculate the range. So I'm going to take that 256 minus, remember we're going to minus our borrowed octet there, 224. And that gives me 32. This is my range, a very important number. I'm going to bring that down here. And I'm going to start writing 0. And of course, my range is 32, so I'm going to do 32. And I'm going to do 64, 96, 128, 160, 192, 224, and finally, that's going to go out to 255. Now, all I have to do is complete my ranges, 0 to 31, 32 to 63, 64 to 95, 96 to 127, 128 to 159, 160 to 191, and 192 to 223. These are the ranges of my networks. Again, it's very important to remember that the bottom and the top is always reserved. So that my bottom entry will be reserved and my top entry will be reserved. And again, the first and the last in each of these will also be reserved. So we're going to cross these out and cross these out. That makes my actual range here 33 to 62. And 33 to 62, if counted up, is of course equal to 30 hosts on each of these networks. 30 here, 30 here, 30 here, 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 and here. All right, so before we move on to the next example, let's talk about slash notation again. And let's figure out what the slash notation for this subnet mask would be. So we know that we have 8, 8, and 8 here. So that we know that the slash notation will be at least slash 24, but we added 1, 2, and 3, which is 24 plus 3 is 27. So this is a slash 27 subnet mask. So you know that a slash 27 when you see it is 255.255.255.224. One of our last examples before we start doing actual problems, we'll do 255.255.255, and this time we'll do 192. Okay, so again, we're going to do binary conversion. Now we're going to figure out what 192 is. You can go ahead and look up here at the graph and know that through binary conversion, we're going to be the first two turned on, and the last 6 are going to be off. That makes these two part of the network, along with all of these. And these 6 right here belong to the hosts. So 2 to the, we're going to have 8, 8, and 8 plus 2, that's 24 plus 2, that's 26. Minus 2 is going to be our number of subnets. And that gives us 6 left over. So we're going to do 2 to the 6 minus 2. So 2 to the 6 is 64 minus 2 equals 62 is the number of hosts on each of those networks. So it's now again time to calculate our range. So we're going to take 256 and minus again our borrowed octet. And that gives me a range of 64. So very important number, going to bring that down here. And again start with 0, 64, 128, 192, and that's going to take us to 255. 0 to 63, filling in the blanks here. 64 to 127, and 128 to 191. Now again, the bottom and the top are always reserved, so this range right here is reserved, and this one is as well. And also on each subnet, the top and the bottom are reserved. So that makes my actual range 65 to 126 and 129 to 190. Interestingly enough, this subnet mask here only gives us one here and the second one here, 2 usable subnets, because the first one and the last one have to be reserved. And of course, if you add 65 to 126, that gives you 62 usable hosts. So now that we've gone through a couple of these, we're ready to actually tackle a problem. So we'll be doing some examples that are actually off of the CCNA and subnetting exams. And I'll walk you through a couple of actual questions that you can expect to see on subnetting. Okay, so here we have a question. What is the last valid host on the subnetwork 192.168.237.0/25? So when you get a problem like this, don't worry too much about the wording that's going on up here. Concentrate on the number first, and we know we have a /25 here. So our first step is really going to be to determine what our subnet mask is going to be. And we were given this /25, but let's get that into a more subnet mask format. So we know that /25 indicates how many bits are turned on. So we know that the first 8 will be on. 1, 2, 3, 4, 5, 6, 7, 8. And then we're going to do 16. Now I've got 24 turned on here, which means that I'm going to turn on only one more. This is number 25. That's right here. So this is the binary format of /notation /25. So now what I need to do is go ahead and fill in these remaining zeros so I get a total of 8 bits. And now I'm ready to calculate what my subnet mask is going to be. So because these are all turned on, I know this is going to be 255. This will also be 255. This will also be 255. And I know that first bit's turned on, so I know that right here, that's going to be 128. Okay, so now we have a subnet mask to work with. So let's go ahead and figure out our number of subnets and number of hosts. So we're going to do 2 to the n, and n being the number of bits borrowed. That's going to be 8, 16, 24, 25 to the 25 minus 2 is going to be the number of subnets. So now let's figure out hosts. 2 to the n, where n is the number of bits that remain. That's going to be 7. So 2 to the 7 is going to be 128 minus 2 is 126. That's our number of hosts per network. So now we're going to take a look at our range. So we're going to, of course, take 256, subtract it by our borrowed octet, and that's going to give us, of course, 128. This is my range. So I'm going to start with 0, and since my range is 128, I'm going to go to 128. Now I fill in the blanks here. So that's going to be 127, and 128 is going to take us to 255. Okay, so I know that my top and bottoms here are going to be reserved. This is actually going to be 1 to 126 and 129 to 254. Remember, you only use the insides that are here. So we now have the information that we need calculated out to solve this problem. So let's go back to the wording. What is the last valid host on the subnetwork 192.168.237.0? Now remember, because these three here, remember, this locks that first part of the network in, we can essentially ignore this part right here. This part right here is reserved for part of the network. That only leaves us this to work with. So what is the last valid host on the subnetwork 0 here? And since we know that that range of 0 to 127, which is actually 1 to 126, again, since you have the 0 here, you bring that down and look at what's going on here. That's this range right here. But since we don't use 0, what they're actually talking about is this range. The last usable range here is 126. So the last valid host on the IP 192.168.237 in the range of 0 to 127 is going to be .126. Congratulations, you have just solved your first subnetting problem. So now let's do another one to keep that confidence level going. So here again we have another word problem. What is the first valid host on the subnetwork that is node 192.168.77.6/30? Again, don't concern yourself or get scared about the word problem at first. We got a slash notation here, so we're going to concentrate on that. We need to figure out what our subnet mask is. So we know a /30 is going to be 8 in the first, 8 here, as well as here. Now we got to figure out what's left over here. So I've got 24 bits here, and I need at least 6 more. So I'm going to take those 6, and 6 plus 8 plus 8 plus 8 is 30. This leaves me with 2 bits left over. Okay, and with this binary information, I can go ahead and determine my subnet mask. So 255.255.255, and I'm going to go ahead and add this up, and I'm going to go ahead and get 252, which is those first 6 bits turned on. So all of these bits belong to the network. These 2 belong to the host, and it's time to figure out our number of subnets and number of hosts per subnet. So I have 30 bits turned on, so 2 to the 30 minus 2 is our number of subnets. Let's go ahead and calculate number of hosts. So I have 2 bits left over, so that's 2 to the 2, which is 4, minus 2 is 2 hosts per subnet. Now I'm going to go ahead and calculate range. So I have 256 minus our borrowed octet, which is 252. And that's going to give me 4. 4 is my range. So we've got a pretty small range here, so I'm going to go ahead and start calculating out. 0, 4, 8, 12, 16. And I would keep going all the way until I eventually hit 255. I'll go ahead and start filling in these ranges. So that's 0 to 3, and 4 to 7, 8 until 11, 12 until 15, and so on and so forth. So because my bottom and top are always reserved, I'm going to go ahead and cross this out. And what I actually have here, since I'm going to cross these out and cross these out, I actually have 5 to 6, which is, of course, 2 hosts, which confirms my formula here, 2 hosts. And here I have 9 and 10 and 13 and 14. So now that I have the correct information, I'm going to go ahead back up here and concentrate on my word problem. And it wants to know, what is the first valid host on the subnetwork that the node 192.168.77.6 belongs to? Now again, since I have these 3 locked in, we don't really have to focus too much on this part of the IP address because that's locked in. What we're really trying to figure out is, what does this belong to as far as the first valid host? So we're going to have to come over here and take a look and see, where is 6 on our chart here, on our range chart. And we notice that 6 is right here in this range. And it wants to know, what is the first valid host on that subnetwork? And the first valid host that I can see on this subnetwork is, of course, 5. So the answer to this question is 192.168.77.5 is our valid host range, our first valid host on that subnetwork. Okay, so that was your second subnetwork problem. Not too bad. Now let's go ahead and do 2 more. So again, we have another word problem. What valid host range is the IP address 192.168.82.59? So we're going to approach this one using the same methodology we've discussed in the last 2 problems. So we're only focusing at first on that /28. We're going to try to figure out that IP address. So we know that /28 is going to have the first 3 octets full. And now we're just trying to figure out, we got 24 here. I need 4 more to make 28. So I'm going to take 1, 2, 3, and 4. And that leaves my last 4 open. So I can now calculate the subnet mask. So I'm going to do 255.255.255. And I need to go ahead and calculate this using binary conversion. And that's going to give me 240. Okay, so now I have a subnet mask to work with. That means this section right here belongs to network. And these 4 belong to hosts. Time to use our 2n minus 2. So we're going to do 2 to the, and I have here 28 minus 2 is our number of subnets. Let's calculate hosts. I have 4 remaining, so that's 2 to the 4, which is of course 16, minus 2 is 14 hosts per subnetwork. And last step is range, 256 minus 240, which is our borrowed octet. That's going to give me 16 is my range. All right, so I'm going to start right here with 0. I'm going to do 16 and 32 and 48 and 64. Do one more. Go up to 80. So 16 each time. Now I'm going to fill in those ranges. And again, you could take this all the way out to until you eventually reach 255. So I'm going to do 0 to 15, 16 to 31, 32 to 47, 48 to 63, and 64 to 79. Now again, my first range is going to be crossed off, and my first and last in each of the subnetworks is also going to be crossed off, making this, of course, 17 to 30, and then 33 to 46, 49 to 62, and 65 to 78. And each of these, of course, is 14 hosts in each subnetwork. Okay, so we're going to go back up with this information and try to solve this word problem. It wants to know the valid host range is the IP address 192.168.82.59. Again, since this is class C and we got all 3 of these locked in, we're not really so much concerned with the first three numbers here because those are locked. So we're dealing with this 59 here, and it really wants to know what is the range that this is sitting in. So we're going to come down here with this 59, and we're going to take a look at where does it fit in. And it fits in this range, 49 to 62. So the correct answer to this problem is, what range does this fit in? It is 192.168.82.49 to 192.168.82.62 is where that range falls into. Okay, so that was our third problem. We're going to do one more to finish up on Class C subnetting. So this one wants to know how many subnets and hosts per subnet can you get from the network 192.168.131.0 with a subnet mask. So here we didn't get slash notation. We actually got a whole subnet mask written out for us, which is nice and easy. So we're going to go ahead and write that down right away. Okay, we're going to convert this to binary, which gives us this right here. Now, this is asking us how many subnets and hosts per subnet. So how many subnets and how many hosts per subnet? This is going to be asking us to use the 2n-2 formulas. So we're going to figure out here using these two things, and we don't have to go all the way through. So we're looking at that word problem, trying to figure out how far we have to take this. So we're going to start off with the number of subnets. And what I have here is, so 2 to the n, which is going to be the number of bits borrowed, which is 1, 2, 3, 4, 5. So 2 to the 5 minus 2, which is going to be 30. So our answer for the number of subnets is 30. So we already have that answer. And then we have 2 to the number of bits that remain, which is 3. So 2 to the 3, which is 8. Minus 2 is going to be 6. Our answer here is 30 subnets and 6 hosts.
If this video was able to help you out, go ahead and click that like button and subscribe for more Tech Thoughts videos.